So I'm going to be talking through some code and showing you some gameplay of my Project 3 for 40 credits. This was an investigation into large language models in games. I'm now showing you the player controller. This uses the enhanced input system in UE5. I had basic controls, obviously movement, looking around, flashlight, interact, jump, and fire. I also had systems that would stop the player movement when they're interacting. This is the player character. This is where the maths, so the stamina was calculated, so sprinting and jumping use stamina. There was also a built-in health system that was also used on the enemies. Now just showing here the interaction with the NPC. So it would start by generating a message, so like the start of a conversation with you. You could then click one of the three options as shown here, and it would respond with a unique message that obviously isn't hard-coded. The unique thing about this system was that it could do world checks during asking questions. So if you ask it if it's found new planets, it can respond with actual information about the world. So if you see me click it here, it will repeat back to the player, you've come to see the swirly clouds on test 5. So test 5 is the next world. So now I'm going to show you the input box. So you can literally type anything into this bot and the NPC will try and respond as the player character they are. So I asked how the day is. I also asked what their name and job is. So each of them have been given specific roles and lore behind the character. And finally, I ask if they have a mission, just a general question. So there is nothing specified about this, but she will make up a response for the player. So now we're looking at the NPC chatbot script. So obviously when it's first interacted with, it will create a llama component. This llama component is the code that interacts with the LLM. It also creates obviously the chat dialog window. And this is very memory intensive. So when the player exits the chat, it needs to destroy the llama component and set it to null pointer. When the llama component starts generating tokens, it will feed this back to the NPC, which then can display it on the HUD. It has to do a bit of parsing, so removing unnecessary text such as the input prompt itself, as the LLM sees it as a prompt. There are also some extra features such as disabling the button when it's not been generated yet, just so the user can't spam inputs to the LLM. This is the topic relay. When a button is pressed, it's linked to an enum of topics. It runs a switch statement. It then either searches the world or the player's mission controller. It can then relay this information in a text-based format into the LLM. So the player never sees this happening. So it looks like the bot just knows things magically, but really it's doing a check. This is a llama component. When it's initialized, it will create a llama class, which is another piece of code that can interface directly with the llama DLL and the llama dataset. It has several variables for the LLM, such as context length and debugging. It also has to bind to several callbacks, including if it has generated a new token, when it has reached the end of the stream, when it has started generating, and when the context is reset. When it is activated, the work is distributed onto threads. It then processes the data every tick, and there has been functionality added to stop and resume generation. It also has memory management, due to it taking potentially up to 8 GB of VRAM when distributed onto the GPU. This is the llama interface that talks with the LLM. On the left is the original code uploaded by Miko onto GitHub. It had the flaw that it infinitely generated text, and it was originally used just for a search like Google feature in Unreal Engine, so it needed some big changes. Get Nano added to this project by getting the start-stop functionality, but his script was broken, didn't launch in Unreal Engine, and would literally crash before it even opened. Using each of these projects as like a base, I added the features that Get Nano added, but got it to work on Mika's original. As well as this, CUDA acceleration was used, but it totally crashed when using, therefore putting the load onto the CPU was necessary. This code, in total, takes a string that is inputted, as well as an opening context, and tokenizes this data and feeds it to the LLM using different threads to make it more efficient. It also has the process of detokenizing the data when it has been processed and generated and needed to turn back into a string. This code also creates the variables for the large language module, such as temperature and p-value, as well as penalties for the LLM. At this point, I need to shout out, obviously, Mika for the original code, but also conversing with me on his original upload on YouTube, as well as in GitHub. I also need to shout out GetAnAmmo, who literally responded to me on the daily for help with code, as well as improvements to his code. And finally, I need to shout out Chi Chang, who messaged me on LinkedIn after seeing one of my posts and recommended using system prompts, which helped with my project immensely. After that was the quest generation. This time, instead of using a local LLM, I used OpenAI's API to generate a JSON file to create missions. This included making a prompt that would return the correct set of data. For each quest, it returned a different type of JSON file. There were 3 different quests. There was collect, go to, and kill quests. Obviously, kill quests could change depending on the enemy type. Collection quests, there was different items, and go to quests, there was different locations. This data was then passed into the player quest component, which had a queue that contained what quests the player had. It also updated the HUD with the AI generated title for the quest and description. This component also handled the steps of the task, as well as the beginning and end of the quest. Each quest derived from a base class called QuestBase. That controlled the overall arching thing that every quest had, so starting and completion and handling the steps of each quest. In the actual quest children, there was obviously stuff for controlling item spawning, enemy spawning, and when the player had completed the step needed. This is me just completing some quests at a higher speed, just so you can see variation of quests. So this is a video of me just recording me playing around with the bots, using their buttons, using input prompts. All of these bots had different personalities. The one I'm showing you on screen is Danny. Danny was a spacecraft IT specialist, but he's very quiet compared to the others. I made loads of different ones, all based around a personality type. This works by using JSON files and then the bot reading them at the start and using that to input them into the LLM. This project was then sent off to be user tested by other people, and they gave feedback, and that stuff's all in the documentation. But their instruction set was to have a chat with these, understand them. There's some difficulties. There is clear issues sometimes where they make spelling mistakes sometimes, but the one that's noticeable is punctuation and them not replying sometimes. Overall, this project though came out pretty good, and for such early technology, I think this is very viable, and I can't wait to actually see it in a properly developed game.